Hello, today we are starting with Furan. Furan is oxacyclopenta-2,4-diene, that is 5-membered oxygen-containing ring, having lone pair of electrons on oxygen. This name is derived from furfur, that is in the Latin furfur means bran, as aldehyde furfural is prepared by distilling bran with HCl, that is where the name comes from. Furan is present in pine wood. It behaves as a resonance hybrid of 5 resonance structures. Furan is having 5 resonance structures. It has resonance energy of 66 kilojoule per mole, and it is aromatic as it is planar and it contains 6 pi electrons and it obeys Huckel's rule of 4n plus 2 pi electrons. Resonance structures. So they can ask you to draw resonance structures of Furan. So here this pair of electrons will shift over here and the bond will give its electrons over at this carbon. Now these electrons will shift over here, again the bond will give its electrons to this carbon. Now these electrons will shift over here, okay, and this bond will again shift to this carbon, so these electrons, and move on. Like that we will get 5 resonance structures of Furan. Now here we are starting with the synthesis from carbohydrate. First synthesis is from pentose. So it's a 5-membered carbohydrate, pentose. In this, when we heat this pentose, it loses 3 molecules of water. So one H, like if you see the blue one, green one and the red one, from where H and OH will come out respectively and leave as 3 molecules of water. And it will form, because CHO over here, so after forming a bond, it forms a furfural, and this furfural upon the reduction will give Furan. Second one, important one, is Pulmonary synthesis, in which 1,4-dicarbonyl compound undergoes, this one is 1, 2, 3 and 4. So 1,4-dicarbonyl compound undergoes cyclization and dehydration in presence of non-aqueous acid medium in benzene to yield Furan. So here 1,4-dicarbonyl compound in presence of phosphorus pentoxide and acid. When we are refluxing these two together in benzene, it will give 2,5-dimethyl furan. Now we go to mechanism. So here if you see, here this is a carbonyl compound, C double bond O. As O is electronegative, its tendency is to draw the electrons towards itself, and because it takes the electrons towards itself, this carbon will possess a positive charge, okay, and because it attracts electrons towards itself, so it will carry जो भी negative charge है उस पे, and the whole system is surrounded by acid, and acid donates proton. So this oxygen will take protons because they are having lone pair of electrons, so they will take protons. And this carbon, as this bond is broken, this carbon will be having a positive charge. Now this positive charge will get neutralized by breaking this bond, okay, and the bond will be formed here, and this H will leave in the system, okay. As we have already taken this H from the system, this H will be given back to the system, okay. Now the next carbonyl carbon, again oxygen will take electrons towards itself, carbon will carry the positive charge. Now in this case, okay, in this case this oxygen will share its pair of electrons and form a bond with this oxygen, with this carbon, and like this cyclization takes place and a furan, and this structure will be formed. In this case, as this oxygen is giving its electrons to this carbon, this oxygen will bear a positive charge, and oxygen being electronegative cannot bear a positive charge. So what it will do, it will break this bond, take its electrons back, and this H will be in the system. Now this, as I already told you, that water is a good living group and it always good whenever you see any OH. It is always like advisable to take proton from anywhere from the system and make this water to leave. Okay, so it takes the water because this O is having a lone pair of electrons, so this will take proton from the system, make water, and because it takes proton, this oxygen will become positively charged. Okay, and this will leave. When it will leave, this bond will break. Okay, it will take this and it will leave, so this carbon will carry a positive charge. Now to neutralize this positive charge, over here there are two hydrogens. One hydrogen will break, okay, and water will leave and furan will be formed. Now, why electrophilic attacks takes place at 2 and 5 positions of furan? It always comes in the give reasons. So when attack takes place at 3 position, what will happen? Just consider this case, 1, 2 and 3. So electrophile is what? Electron loving group. So they want electron. So for this reason, if this bond breaks and gives electrons at this position, electrophile will get attacked over here. And because this bond already broken, this carbon will carry positive charge. Now to neutralize this positive charge, electrons from this oxygen will get shifted over here and form a bond, and oxygen will bear a positive charge. Okay. Now consider the next case, that is attack at second position. So if we are considering the electrophilic attack at second position, this bond will break and give its electrons over here, and due to which here is a positive charge which will get neutralized by shifting this bond over here. Then charge will come this side. Now this oxygen will give its electrons towards this positively charged carbon, and then positive charge will come on this oxygen. So if you compare, then here are more canonical structures than the previous one, than the attack at 3 position. So that is why greater number of canonical structures, so greater is the stability. Now we will move to the chemical reactions. Here, Gombach reaction. So Gombach reaction is nothing but the reaction with benzene diazonium chloride. Here furan reacts with benzene diazonium chloride in presence of NaOH, leaving. Here aryl group will get attached at 2 positions. As we know always that electrophilic attacks takes place at 2 or 5 positions. So here benzyl, this aryl group will get attacked at 2 positions. Then nitrogen will be released along with water and sodium chloride. Second one is the reaction with N-butyl lithium. Here N-butyl lithium. So yeah, at this position, being a electrophile, this lithium will get attacked. Okay, and again on reaction with carbon dioxide, here it forms furic acid. And this one is a reduction process in which furan when reacted with will get reduced in presence of nickel and 2 molecules of hydrogen at 25 degrees Celsius. It will form tetrahydrofuran, which again on reaction with HCl, what will happen? This oxygen will break this bond, okay, and this proton, due to this acid, the system is surrounded with protons. Now this proton will get attached to this OH and the ring will get open, and the proton will get attached over here and the remaining Cl will get attached to this carbon. Okay, so HCl का H इधर आ गया और Cl यहाँ पे आ गया. So now again it will get react in presence of HCl, and as I told you, whenever there is a OH, we have to get rid of water. We have to remove that by making water. So again with the HCl, this H will get attached over here and forms water, and this chlorine attacked at this carbon, because this bond breaks, right? So this bond breaks and this carbon will bear a positive charge. This chlorine having negative charge gets attacked to this carbon, and this dichlorobutane will be formed. Again in this compound will get reacted in presence of 2 molecules of HCN. This chlorine will be replaced by CN, and then hydrolysis reaction, it forms adipic acid. These are some of the electrophilic reactions. First one is a nitration reaction which takes place in presence of conc HNO3 and acetic anhydride, and it gives attack at 2 position. Then sulfonation reaction in presence of sulfur trioxide and pyridine at 100 degrees Celsius gives forms furan 2-sulfonic acid. Then in presence of Friedel-Crafts acylation reaction in presence of acetic anhydride, boron trifluoride and ether, it forms this 2-acetyl furan. Then this one is a bromination reaction. In dioxin as a solvent at 0 degrees Celsius, it forms 2-bromofuran. Now in the chlorination reaction, okay, when chlorine at 40 degrees Celsius, it forms 2-chlorofuran, 2,5-dichlorofuran plus 2,3-dichlorofuran. So it's a mixture of chlorofuran. Okay, so chlorination process is not that much advisable to do because it gives a mixture and not a proper product. Next is Friedel-Crafts alkylation, in which in presence of tin chloride, alkyl chloride, it gives 2-alkyl furan. Then this one is a Gattermann-Koch reaction in presence of HCN, HCl and AlCl3. It forms a formylation reaction. So formyl group will get introduced over here, which is also known as furfural. Then furan undergoes oxidation. Here the ring will be opened and aldehyde group, 2 formyl groups will be added, and this is known as succinaldehyde. Then Willsmere-Hack formylation. As the name suggests, is a formylation in presence of dimethyl formamide and POCl3, which introduces CHO group, which is also known as furfuran. Now this reactions of furan is mercuration. Here in presence of mercury chloride and methanol, there is mercury chloride group will get attached, which again in presence of acetyl chloride, it forms acetyl group will get introduced. Now these are the reactions of furfural. There are 2 molecules of furfural in the reaction with NaOH. It will form sodium salt, okay, sodium salt and alcohol. Okay, now as there is no alpha hydrogen, this aldehyde will not give Cannizzaro reaction. Okay, now this one is a benzoin condensation. Okay, benzyl benzylic acid rearrangement which will give furylic acid. Then in this process mercury acetate will turn furoic acid to 3-acetoxy-mercury furan. This one is the most important one, is a Diels-Alder reaction. Like they will ask why furan is furan gives Diels-Alder reaction. Okay, so here due to electronegativity of oxygen, okay, electron delocalization is not overly effective because oxygen, what oxygen will do, oxygen will attract all the electrons towards itself. So delocalization, electrons will not move towards the system that effectively as in other system. Okay, so it has got tremendous electrons, like lot of electrons on oxygen, and it can give that electrons to dienophiles. Okay, and can undergoes 4+2 cycloaddition. So in presence of dimethyl malleate, it gives adduct. Now why furan is aromatic? Now furan is an aromatic compound because one of the lone pairs of electrons on the oxygen atom is delocalized into the ring, it is moving. Oxygen atom is sp2 hybridized with one of its lone pairs in a p orbital. This creates cyclic pi system with 6 electrons, as I already discussed at the start. It follows Huckel's 4n+2 rule and hence it is aromatic. In electrophilic aromatic substitution, is why it is easier in furan than benzene. It is easier in furan because electron donating effects of the oxygen heteroatom. It is attracting electrons towards itself as well as it will donate also. So examination of the resonance contributors shows the increased electron density of the ring, leading to, because as there are more electrons available on the ring, they attract more to electrophiles, and that is why electrophilic aromatic substitution will take place more easily. Then benzene acts as a nucleophile because all the electrons are moving inside and there is no extra electrons on the system. They act as a nucleophile to replace the substituent with new electrophile, and if they want any electrons, benzene needs to donate electrons from inside of the ring, and so that is why, and the aromaticity will be lost if benzene has to do that. Then so benzene becomes less reactive and deactivating groups are present on it. Now why furan is less aromatic than benzene? Because in benzene all pi electrons are involved in forming the aromatic sextate. All bonds and electrons are same. In furan, the oxygen being more electronegative than carbon, they pull electron cloud towards themselves, and thus there is an uneven charge distribution. Delocalization is not that much effective, and more electronegativity of the atom, less aromatic is the compound.